Hello, I'm Aaron Lohr, and this is the Endocrine News Podcast. Today, we're talking about an endocrine disrupting chemical called Bisphenol A, or BPA. You've probably heard about it, or at least have seen the ever-increasing number of products claiming to be BPA-free. Well, what exactly is BPA? Why is it harmful? What can we do about it? And does BPA-free mean risk-free? Joining me today to walk us through all this is Dr. Heather Pattisall, Professor of Biological Sciences and Associate Dean for Research at North Carolina State University. Thank you for joining us today, Dr. Pattisall.
Thank you for having me.
Let's just go ahead and jump in. BPA, what is it and how is it used?
So it's called Bisphenol A, which is basically two bisphenol rings joined together, and it's used to make plastics stiffer and harder. So for example, if you get a water bottle out of the vending machine, it's a squishy kind of plastic, but if you have an Nalgene or similar plastic bottle, it's harder. It's Bisphenol A that makes that plastic harder. It's also used in the lining of cans and in other kinds of plastic products.
So is it fair to say that the BPA is basically everywhere? Because I think of hard plastics and I'm like, oh boy, I'm looking around my room right now, a lot of hard plastics.
Yeah, because plastics are everywhere, Bisphenol A is everywhere. It's not in all plastics. It's in polycarbonate plastics and some other types of plastics. But like you said, plastics have become pervasive in our world. And so unfortunately, BPA has too.
So it's very likely that all of us listening to the podcast right now, sorry listeners, we're exposed to BPA probably on a daily basis. Why should we be concerned about BPA exposure, and why is even a little exposure a bad thing?
So Bisphenol A can fool your body's endocrine system by either mimicking or blocking the action of estrogen. So it's an estrogen disruptor. And estrogen is used for all kinds of things. We think about estrogen in the role of female reproduction, but it's also a really important hormone during development in both males and females. It's important for bone health and a whole lot of other endpoints in the body. And so when you introduce a chemical in your body that can disrupt estrogen, you got a lot of organs that could be impacted by that. And obviously the greatest concern is during development. So exposure during development when hormones are doing important organizing roles like organizing organ development, you can get a permanent effect with exposure to a chemical that disrupts their action.
And a lot of times you hear people think about a bad chemical. You'll sometimes maybe hear the old phrase from toxicology that the dose makes the poison or something along those lines. But with endocrine disrupting chemicals, including BPA, that's not always true, is my understanding. That sometimes a small exposure can have a different sort of effect and a significant effect. Is that true?
So that observation, the dose makes the poison, came from an era where we were truly just dealing with poisons. Chemicals that if you ate enough of them or got exposed to enough of them, you would die. So you would try to limit how much that was taking in. We now know that a lot of chemicals are not necessarily poisons. For example, you could have a massive high exposure to bisphenol A and it is not going to outright kill you. Instead, it has activities that are much more subtle. And so that's what makes them different. And that's why they don't fall under that classic axiom that really only applies to poisons.
Now, recently, the European Food Safety Authority, the EFSA, released some new findings on BPA. Can you tell us a little bit about these findings and why we should take note?
Yeah, so their regulatory agency, a lot like the FDA in the United States. And so part of their job is to take the scientific literature surrounding a chemical like bisphenol A, compile it, analyze it, and then make a decision as to whether or not there's enough evidence to show that a chemical is potentially harmful. And so they've done this at different intervals over the years, and this was their latest one. And using data, ironically, that was generated by a project that was at least partially funded by FDA, they concluded that there were significant enough effects to make the recommendation that they lower what's considered the safe exposure level 100,000 times. 4 micrograms per kilogram body weight, which is already quite low, to 0.04 nanograms per kilogram body weight. And so that's a level low enough that there really should be no bisphenol A in that product, or it should be almost negligible. So it's effectively reduced what they consider a safe exposure level to very, very near zero.
Wow, that is quite the reduction. I'm sure, like you said, the EFSA is kind of like the European counterpart to the FDA. Recently, the Endocrine Society, along with the Environmental Defense Fund, the Breast Cancer Prevention Partners, Consumer Reports, and several others, sent a formal petition to the FDA regarding BPA. What are these groups asking?
So they're basically asking the FDA to take the same approach and to make the same conclusion. So if you have a regulatory body in Europe that's done a considerable amount of work and effort looking through this literature and concluding that BPA exposure is essentially unsafe, we're asking FDA to essentially copy that and make the same conclusion here in the US so that we can harmonize that at both sides of the Atlantic.
So the EFSA made this call for a much heavier, more intense restriction on the use of BPA. What was it that they had found that made them call for this tighter restriction?
Well, I think it's first important to understand that what they're looking for in a risk assessment is the most sensitive endpoint. So you're going to want to regulate a chemical based on the most sensitive endpoint in the most sensitive group, right? So you could look at a lot of things like, does it increase cancer risk? Does it change brain development? In this case, the most sensitive outcome was an immune system response. So there was an increase in T helper cells, which then drove a higher risk of allergic lung inflammation, among other things. And so it wasn't an endocrine endpoint in this case. That was the most sensitive. It was immune.
Right now, a lot of people who are listening who maybe haven't focused a lot or thought a lot about BPA or some of the endocrine disrupting chemicals that we know that are out there are wondering if there's anything that we can do to limit our exposure to these chemicals. What would you say to these people with those concerns?
So the easiest thing to do is try to limit the use of plastics as a food contact material. So if you can heat up your dinner in something other than a plastic dish, that's good. Even if you have like a frozen food dinner, if you can just remove it from the packaging, heat it up on a regular plate, that kind of thing, that's the simplest way to limit exposure. Canned food is also going to contain bisphenol A because it's most likely in the can linings. BPA has been phased out of use from a lot of water bottles, so you'll see that sticker on the side. But in many cases, they've replaced it with another bisphenol. There's a bisphenol alphabet soup, so we only just regulated A. We have many, many other letters to go. And the one that's gotten a lot of attention by other endocrine society scientists is bisphenol S. And that one, unfortunately, also looks to be an estrogen disruptor.
And not to cause too much worry amongst the listeners, but if something were to have BPS in it, a product could say BPA free, but still have BPS, and really we just wouldn't know. Is that true?
That's unfortunately true, yes. But I will say, as bisphenol A metabolizes very quickly in the body. So it's not something that's going to stick around and persist like a bunch of other chemicals. So if people are concerned, if you start changing your habits, your body burden will go down very fast.
So let me ask you this. If there's so much evidence and science behind BPA being the harm that it can be, why does it seem so difficult to be able to get rid of it? Get it out of here. Hey, we see what this is and what it can do, and yet nevertheless, here it is everywhere.
It really is an uphill battle, and there are the economics of it. I mean, that is the reality. Unfortunately, it's also how the regulators choose to evaluate the science. And so EFSA has taken a much more rigorous approach. They cast a wide net for the types of papers and sciences they're going to look at. And then they apply systematic criteria using something that's pretty close to a systematic review, something that you would do for like a clinical study or a clinical trial to evaluate all of that evidence comprehensively. And they do a risk of bias analysis, and then they get the data at the other end. A lot of scientists feel like that is a much more rigorous approach than what FDA does, where it tends to be pretty subjective, and they eliminate more than 99% of the studies that could be used to evaluate the safety of the chemical. So I would say that leaves them pretty blind. And if you're eliminating most of the evidence it's easy to come to an erroneous conclusion. So for example, the FDA set its TDI in 1988 at 50 micrograms per kilogram body weight, and they've refused to budge on that number. And EFSA or EFSA has moved the needle now twice because they've been much more proactive at pulling in new data. And I and other endocrine society scientists were on a project called Clarity BPA, which was a collaborative project between FDA and NIH. So this was supposed to generate really high quality data that could be used for risk assessment. And EFSA just used it, and FDA still refuses to use that data for their own risk assessment for reasons that are really known only to FDA. And so until we can get around those barriers, it's going to be tricky. But I think this new move by EFSA helps because it demonstrates that rigorous analysis and risk assessment can be done, and that there is high quality data that could be used to make better decisions that protect public health.
That's wonderful. I really appreciate you coming on and talking a little bit about how EFSA has continually evolved in their response to BPA and what they're doing, and just how you, the Endocrine Society, and these other groups are sort of joining their voices together to make sure that the FDA also hears how important this is and how their response maybe needs to be evolved as well. Thank you so much for coming on the podcast and talking about BPA with us.
Well, thank you for the opportunity.
So that's all for this episode. I hope you enjoyed it. If there's a topic you'd like to hear us cover on the podcast, please let me know by emailing me at podcast@endocrine.org. And if you didn't already know, registration is now open for Endo 2022, the Endocrine Society's annual meeting, which will take place in Atlanta, Georgia, and also virtually on June 11th through the 14th. This meeting is the seminal meeting in hormone health and science, and discounted early registration is available now. You can learn more at endo2022.endocrine.org. Until next time, thanks for listening.
Endocrine News podcasts are a free service of the Endocrine Society. To learn more or to become a member, visit the Society's website at www.endocrine.org.